Lovely question here about a magic hexagram. So we're told that it uses 12 different prime numbers. 5 numbers, including the smallest and the largest, are shown on the diagram already. So the smallest prime is going to be 29, the largest 73. I'm going to write down all the primes, therefore, from 29 to 73, just working up through them carefully, trying to recognize them. So we only need to go up by odd numbers each, well, sorry, by 2 each time. We can avoid the even numbers. So 31 is okay. 33, 35, not, but 37 is. 39 is 3 times 13. Then we're into the 40s. 41 we're actually already given. 43 is another. 45 is divisible by 5. We can ignore any number that ends in a 5. 47's on our list already. And then 49 is 7 times 7, so that's not one. 51 can be a tricky one, but it looks like it might be, but actually it's divisible by 3 because the digit sum is 6. That's always a good shout just to check whether numbers are prime, like a quick divisibility test, because you don't have to test many. You only actually have to, if you took 47, then you only have to divide by the primes up to its square root to be able to check whether it's prime. So you can check 2 very quickly. That doesn't go into it. You can check 3. The digit sum is not a multiple of 3. Check 5. It doesn't end in a 5 or a 0. And then actually that's it. I mean, you could check 7, but 49 is a multiple of 7, so 47 is not. And then you can stop because if 2, 3, and 5 don't go into it, actually we don't even need to check 7 because 47 is less than the square root of 47 is less than 7. Then because 2, 3, and 5 don't go into it, there's nothing like above that would go into it because you have to have something either side of the square root. So I'm just trying to explain like how you could do it if you can't quite see it straight away. So rule out 51, but 53 is okay. 55, no. 57 is another one where the digit sum adds to 3. 59, we can also be pretty sure because we're expecting 73 to be the 12th. Then we're into the 60s. 61, yes. 63 is 9 times 7. 65, no. 67 is okay. 69, again, digit sum of 3. 71, um, 71 is okay. And actually that is our 11th, which gives us 73 as our 12th. So those are the primes that we're interested in. Now let me just put a little line through the ones that we've already used. 29, 67, 73, 41, and 47. Okay, we need to carefully and logically explain how we're going to work out P. And a good shout is to look along this row because it already contains 3 primes and along this diagonal. Remember, the sums are the same. So we might be able to figure out what these two are because they'll be the missing primes to make the sums the same. 29 plus 67 plus 47, 14, 23, and then 10, 11, 12, 13, 14. So 143 plus the missing prime along this diagonal, and then 73 plus 41 plus 47 gives 11, and 8, 15, 16. So 161 along here, plus the missing prime. So that means I want to find 2 primes that differ by 18, because that is the difference between 143 and 161. So seek, because if I can find, if there's only 2, then they must fit in. Okay, so I'll just go through them in turn. So 31, no, if I add 18, I'll get to 49. 37, I'll get to 55. 43, I'll get to 61. So that could work. 43 and 61. And then 53 goes with 71. Oh, so I've got 2 options here. 43 and 61 or 53 and 71. So we're just going to have to look at these on a case by case basis. Case 1, let's go with 53 and 71. So then the total, let's call it the magic number, is going to then equal 143 plus 71. I've just taken the smaller sum and added the larger prime that I added. And that is going to give 214. So let's just check if that is going to be okay. Because if I look along this diagonal now, then I'll get 41 plus 67, which gives 108. And then 214 minus 108 is equal to 106. So require a sum of 106 from two primes. Let's see if that's possible. Remember, in this scenario, we've actually ruled out 71 and 53. We've already used them. Can we get 106 anyhow? Well, if we go with 31, that's too small. 37, too small. 43, I'd need 63. Again, I think that's not an option. That only leaves me with 59 and 61, and that doesn't give me 106. So what I'm trying to say is that this is not possible, so we can rule out case 1. So case 2 is then 43 and 61. Must be this for it to work. Although I suppose we shouldn't assume it. There is, in theory, a possibility that it won't work at all. But I think we can safely assume in this question that there is going to be an answer. Okay, so if that is the case, then what I need to do is I can put 43 here, and I can put 61 here. And the totals, so we've got now, before I had a total of 124 that I was adding. Oh, sorry, I can just do, okay, magic number. The magic number is now going to be 143 plus 61 to give 204. Okay, just underline that. And we've also eliminated 43 and 61. We're doing really well, by the way. There's quite a lot of steps to be able to get P. What I'm going to do now is look along the lines that contain two primes, because then we know the magic number, so we can work out hopefully what the two others are, even if we don't know exactly which way around they're going. So I've got this blue diagonal, and I'm going to look along this purple diagonal. Okay, blue diagonal first. 29 plus 73 is equal to 102. And then 204, a magic number, minus 102 is also 102. So I'm seeking out two of the remaining primes that add to 102. And it's got to be 31 and 71. They're the only two. So I know that both of these, well, these are 31 or 71. This one and this one here. I just don't know the order at the moment. But I can cross them off. Okay, brilliant. Down to 3 primes. So for the purple line, we've got 41 plus 67, and that is 108. So then 204 minus 108, we can minus 100 first to give 104, minus 4 to get this to 100, and then minus another 4 to give 96. Okay, do any of these three, or pair two of these three, add to give 96? 37 and 59 do. So 37 or 59 will go here or here. And the result, in fact, is that if this is going to work, then it must be that P is equal to 53. Because that is the remaining one that I've not used. Now, whilst we have our answer, it's probably going to be okay. We should really, at this level, just check that the grid works and finish filling it in. So if I go along this line now, then I've got 96. And if I do 204 minus 96, that's going to get me back to 108. So I'm looking to use a pair of these to get to 108 now. So it's got to be 71 and 37. So I'm saying that that must be 71 and that must be 37 for that to work. And then I'll have 31 here and then 59 here. So all I would say at this point is to just double check that. I mean, we've already used a lot of like used the magic number to help us work out the missing numbers, but just confirm to yourself and whoever's marking this that like every row does add to 204, and then you'll know for absolute certainty this is our magic hexagram. It all checks out, and P is 53. Okay, very well done on this question. It's a tough one because you have to show your steps all logically, work through it. You might not have gone, you might have obviously gone down the wrong path. Sometimes it might not be quite as concise as this. I mean, this is still quite involved, but you need to be able to explain it. That's the main part of this Olympiad, justifying your steps, um, and following along the logical steps.